day, graded students. Welcome again to our math tutorial. For quarter 3, weeks 3 and 4, we will be illustrating triangle congruence and illustrating SAS, ASA, and SSS congruence postulates. Are you ready? Let's get started. Lesson 1. Illustrating triangle congruence. By now, you must be well aware of the definition of a triangle. That is, it is a two-dimensional figure with 3 sides, 3 angles, and 3 vertices. Let's check the figure. We have there triangle ABC. Triangle ABC has 3 sides. We have segment AB, segment BC, and segment AC. It has also 3 angles. We have angle A, angle B, and angle C, and 3 vertices, point A, point B, and point C. In illustrating triangle congruence, we have to remember these important ideas. 2 or more triangles are said to be congruent if their corresponding sides have equal lengths, and their corresponding angles have equal measures. Congruency is a term used to describe two objects with the same shape and size. This is a symbol for congruency. CPCTC is an acronym that stands for Corresponding Parts of Congruent Triangles are Congruent. We have to remember, congruency is neither calculated nor measured, but it is simply determined by visual inspection. Before going into the details, it is important to know how to mark different sides and angles with a certain sign which shows their congruency. You will often see that the sides and angles of a triangle are marked with the little tick marks to specify the sets of congruent angles or congruent sides. Now you will see in the diagram we have 2 triangles, triangle ABC and triangle DEF. The corresponding sides with 1 tick mark have equal length. Segment BC is congruent to segment EF. The corresponding sides with 2 tick marks also have same length. Segment AB is congruent to segment DE. And the corresponding sides with 3 tick marks are equal as well. Segment CA is congruent to segment FD. Same goes for the angles. The corresponding angles with 1 tick marks have equal measure. Angle A is congruent to angle D. The corresponding angles with 2 tick marks also have the same measure. Angle C is congruent to angle F. And the corresponding angles with 3 tick marks are equal as well. Angle B is congruent to angle E. Since the corresponding sides and angles are congruent, we can conclude that triangle ABC is congruent to triangle DEF. Now we have other possible congruent statements. We can also say that triangle BCA is congruent to triangle EFD. Triangle BAC is congruent to triangle EDF. Triangle CAB is congruent to triangle FDE. Triangle CBA is congruent to triangle FED. And triangle ACB is congruent to triangle DEF. These 6 congruent statements are all the same. Lesson 2. Illustrating SAS, ASA, and SSS congruence postulate. Before we proceed, we have to define first included side and included angle. Included side is a segment between 2 angles of the triangle. Let's look at triangle ABC. The side with 1 tick mark, segment BC, is the included side of angle B and angle C. The side with 2 tick marks, segment AB, is the included side of angle A and angle B, while the side with 3 tick marks, segment AC, is the included side of angle A and angle C. Included angle is an angle between two sides of a triangle. Let's look at triangle DEF. The angle with one tick mark, angle D, is the included angle of segment DF and segment DE. The angle with two tick marks, angle F, is the included angle of segment DF and segment EF. While the angle with three tick marks, angle E, is the included angle of segment EF and segment ED. I hope this concept is clear to you, because this will be used when we work on SAS, ASA, and SSS congruence postulates. Triangle congruence postulate. 1. Side-angle-side congruence postulate, or SAS. It states that two triangles are congruent if two sides and one included angle in a given triangle are congruent to the corresponding two sides and one included angle in another triangle. Let's look at this figure. We have triangle ABC and triangle PRQ. The two corresponding sides with one tick marks have equal length. That is, segment AB is congruent to segment PR. The corresponding sides with two tick marks also have equal length. Segment AC is congruent to segment PQ. In triangle ABC, angle A is the included angle of segment AB and segment AC, while in triangle PRQ, angle P is the included angle of segment PQ and segment PR. The corresponding angles, angle A and angle P, have the same number of tick mark. These two angles are congruent, angle A and angle P. So therefore, triangle ABC is congruent to triangle PRQ by SAS postulate. 2. Angle-side-angle congruence postulate, or ASA. This states that two triangles are congruent if their corresponding two angles and one included side are congruent. Let's check the illustration. We have there triangle ABC and triangle RPQ. The two corresponding angles, angle A and R, have the same number of tick marks. So they have equal measure. Angle C and angle Q have also the same number of tick marks. They also have equal measure. In triangle ABC, segment AC is the included side of angle A and angle C, while in triangle RPQ, segment QR is the included side of angle R and angle Q. Now, if you notice, segment AC and segment QR are congruent because they have the same number of tick mark. Therefore, triangle ABC is congruent to triangle RPQ by ASA postulate. 3. Side-side-side congruence postulate, or SSS. This states that two triangles are congruent if their corresponding three sides are congruent. Let's look at the two triangles. The corresponding sides with one tick mark are having equal length. The corresponding sides with two tick marks also have equal length. And the sides with three tick marks are equal as well. Now, since the three corresponding sides are congruent, therefore we can say that the two triangles are congruent by SSS postulate. To sum up, we have three triangle congruence postulate: SAS, ASA, and SSS. To help you understand better, let's try to explore some of the activities. Let's have activity 1. Let ABCD be a parallelogram and AC be one of its diagonals. Number 1. How many pairs of congruent statements can you create from the given figure above? List them all. We have 6. Triangle ABC is congruent to triangle CDA. Triangle BCA is congruent to triangle DAC. Triangle CAB is congruent to triangle ACD. Triangle ACB is congruent to triangle CAD. Triangle BAC is congruent to triangle DCA. And triangle CBA is congruent to triangle ADC. Number 2. Give the pairs of corresponding angles of a triangle. We have angle B is congruent to angle D. Angle BCA is congruent to angle DAC. And angle BAC is congruent to angle DCA. 3. Give the pairs of corresponding sides of the triangles. We have segment BC is congruent to segment DA. Segment BA is congruent to segment DC. And segment AC is congruent to segment CA. Number 4. What can you say about triangle ABC and triangle CDA? So since the corresponding angles and corresponding sides of the two triangles are congruent, we can say that triangle ABC is congruent to triangle CDA. I hope this is all clear to you. Let's try another activity. Activity 2. Indicate the additional information needed to enable us to apply the congruence postulate. For number 1, we have there given corresponding angles, angle C and angle E are congruent, and the corresponding sides, segment BC and segment DE are congruent. To make these two triangles congruent for ASA, angle B is congruent to angle D. For SAS, segment AC is congruent to segment FE. Let's go to number 2. Given corresponding angles, angle A is congruent to angle D, and the corresponding sides, segment AB is congruent to segment DE, and segment AC is congruent to segment DF. To make these two triangles congruent for SSS, segment BC is congruent to segment EF, and for ASA, angle C is congruent to angle F. I hope the lesson for this week is clear to you. Thank you for listening. Once again, this is Bunyasa Kappa, your math teacher.